Chapter 11-4, Inscribed Angles. And we're moving along on this wonderful, beautiful Saturday. I hope everybody is getting out and going to enjoy this weekend. I'm not. First example. And I think I'm gonna do a little proof after this example, or after a few examples, and show you why this works. But it's pretty straightforward. So we got the diameter of right here, JK, and then we have this angle right here. We want to find out what this angle is. Boom. We don't know that angle. But since it's the diameter, this whole thing is 180, right? So we're going to subtract 100 from it, 180, and then we give this 80. Now, one of the rules of an inscribed angle is just basically the inscribed angle is 1/2 the measure of the angle. Measure of the angle is equal to 1/2 of the arc. So we're just going to take half the arc. This is 40 degrees. I'll show you why in a little bit. But that's pretty much the definition we're working off. This is half of 80. We can make it more complex than this, so let's take a look at the next example. I'll call these our little Star Trek badge problems because it reminds me of that Star Trek symbol. Okay, so what we have is a central angle, so we got to use a couple of definitions here. Central angle is equal to the arc that it is subtended right here. So this is 22, and again, this angle binds the same arc. It comes up with the same arc. So this is going to be 11. All right. Last example. Here we're putting a little bit more together. And AD is the diameter. That's kind of important to know. But even if it didn't, if I had the center circle right here and you saw the line coming right through it, we probably intend that to be a diameter. So what we have is a central angle. So this arc right here is 80. And if this is a diameter, this means that this is 100. And look at this. This is a point of tangency. That means this line comes across and hits that circle exactly this one point. So this is a tangent line. And this angle formed right here is an inscribed angle. It has the properties of an inscribed angle. And we're looking for this angle. We're looking for this angle right here. Not that one. That's a no-no. So I got to erase that part. Okay, we know that one's 90. Because this is a tangent line, this is essentially the radius or diameter. That makes a 90-degree angle. We're looking for this one right here. Well, since this is a point of tangency, and this kind of is like an included angle right here, so we're going to do the same thing. We're going to cut this in half, and this is going to be 50 degrees. So we know that this is 40, by the way. All right, so this is 50 degrees, half that 100. And there's a couple other ways to look at that, and when we go into outside the circle, we would say big arc minus little arc. Well, there's no little arc to minus, so we divide by 2, and it comes out that way as well. Okay, so that is it for this one, and just remember the definitions of central angle. They're equal. Inscribed angle, which means the vertex is on the circle, is going to be half the arc that it subtends. That is it. Now, Mozart, do you want to take the EOC star test? You do? Good. Did you study? What are you going to do when you take the test? You going to do that? What else?